Record. So yeah, so while I'm streaming, it'll auto save, like my Twitch auto saves the videos and keeps a record of them. Um, but then I take the manual recording. So while I'm streaming, I'm also manually recording to my computer, and I'll take that video recording and I upload that to YouTube. So yeah, Twitch will auto record your videos if you have it enabled. So Valen, this is the last set of notes. We're gonna do notes today and Monday, and then on Wednesday we'll work on the homework, and then that'll really be it. So we really only have like 2 days left of notes, and then 1 day of practice and 1 day of review. Oh, we're on. Okay, sure. I can do Roman number 4. That's fine. Roman number 4. We'll call it percents and formulas. Adjust my camera a little bit. Let's see. Thanks, Trinity. Appreciate the compliment. So Olivia, I know that some of you do have AP test. Your AP tests are only going to be an hour, but you can still, of course, turn in anything late or make up stuff next week. Sorry, Olivia Christensen. Yeah, your internet must just be struggling today. Yeah, I'll have the video posted before noon today, so you can go watch it then. Yeah, Olivia, I mean, you can wait and watch the videos on YouTube. And technically, all the week of the 15th to the 22nd, anyone can use that week as makeup work. Otterstrom did. Mr. Otterstrom did. He's a fantastic teacher, so he deserved Teacher of the Year. But yeah, he got it this year. Paul Otterstrom, Woodshop. He's a woodshop teacher. He does a really good job with woodshop. Okay, so percents and formulas. Letter A. Percent composition. Oops, if I can spell. Yeah, he also sings Trinity. Yeah, he lets people make guitars. He does a fantastic job with an elective subject. All right, percent composition. Number 1. Let's do. What if I ask the question? Something like, what percentage of water, right, H2O, is hydrogen? Right. What if I ask the question, what percentage of water is hydrogen? There's a couple different ways you could answer that. So Zach brings up 66%. So you could say that, in water there are 3 atoms, and you could say that, 2 out of the 3 atoms are hydrogen. Trinity says, we've got 2 atoms. Half of the atoms are hydrogen, half of the atoms are oxygen. 1/2, right? Those are both like okay ways to think about it. But the question is, whenever someone asks what percentage, it's usually implied that they're doing percentage by mass, right? So really, most of the time when they say percentage, they really mean mass percentage, right? And in order to do that, you have to look up the weight, right, from the periodic table. Yeah, Chris, you do the weight of the molecule. So we would look up water on the periodic table. So you guys have maybe done this enough by now, but just to double check, let's pull up the periodic table. So hydrogen, right, has a mass of 1. Oxygen over here with a mass of 16, right? So total, right, we have 18 grams per mole. All right. So if we're going to do a percentage of hydrogen, okay, the percentage of hydrogen is going to be 2 divided by 18 times 100. Similarly, the percentage of oxygen would be 16 out of 18 times 100. Okay. So 2 out of 18, it's 1/9. So this is like 11.1%. And this would be 88.9%. Okay. So we could say, right, we could ask the question, if I asked you the question, what's the mass percent of water is hydrogen, or what percentage of water is hydrogen by mass, it's going to get a little bit harder, Chris, don't worry. I always start you guys off easy. All right, so 11.1% hydrogen, 88.9% oxygen. Straightforward. It's not going to get a ton harder. This unit, in my opinion, is really straightforward. It's just sometimes the problems take a little bit of time. So I want to have you guys do another one. So sometimes this is called, this together is called the percent composition. That's just kind of the name of it. We would say that like the percent composition of water is 11.1% hydrogen and 88.9% oxygen. Okay, we could do glucose. That's a little bit larger than I want to do. Let's do, I think this chemical is called Phosgene. Yeah, Phosgene. It's a nerve agent. So what is the percent composition for Phosgene, which is COCl2. So carbon, oxygen, and 2 chlorines. No, I'm good, Xander. I'm good. All right. Oh, is that insulin? That's fun. C257. I didn't realize insulin was that big of a molecule. Cool. Okay, so what's the percent composition for phosgene, COCl2? So the first step is going to be to find the total mass of COCl2, and then take the weight of carbon over the total, the weight of oxygen over the total, and then the weight of the 2 chlorines over the total. So go ahead and take a minute, pull up the periodic table, see if you guys can start this one. Sander flexing his diabetes. Cool, Colorado. All right, I'll put the question down on the bottom, and then the periodic table overlaid. So again, we're doing phosgene, COCl2. Oh, it's cold. My house is cold this morning. I did add some files this morning, Trinity. Oh, can you not see the chlorine? Oh, yeah, if you're on a phone, you probably wouldn't be able to see it. Chlorine's 35.5. Sorry, Dave. You just had too many E's. I can't remember what the limit is on spam. There are 2 of them, Drake, so you do have to multiply it by 2. All right. So let's see, we got to find the total here. Oh, it's 99. That's convenient. 98.91. Fancy. Oh. It's because it has too many symbols. Let me disable that filter. All right, so the percentage of carbon is going to be 12 out of 99. The percentage of oxygen will be 16 out of 99. Oops. And the percentage of chlorine will be 71 out of 99, right? Because we got to factor in the fact that there are 2 of them. Good. Looks like you guys got it. So 12 over 99, which is going to be really close to 12. It's 12.1. $16.2. 71.7. All right. So we would say that yeah, so you can do, I would argue that you can do like I would go to the 10th place. Yeah, I got to do 0.5. Yeah, Drake, you got to do 0.5 on the chlorine. All right, so 12.1% carbon, 16.2% oxygen, and 71.7% chlorine. Now notice what happens if you add these 3 numbers. What does it add up to? 100, right? It should add up to 100 because that's all that's in the compound. Okay, there's nothing else in the compound, so it should add up to 100. Okay, good. All right, we are on track. It's 8:50, and then now we're moving on. Letter B. Okay, so the cool thing about this is, instead of taking a compound and finding the percentages, you can actually take the percentages and find the compound. And that's kind of what we're going to be doing next, is taking the percentages and turning into the compounds. Drake, get better internet, man. Get better internet. Get better internet. Okay, so we're going to start off with something called empirical formulas. Okay, so we can say, so zircon is 49.76% zirconium, 15.32% silicon, and 34.91% oxygen. Okay, so zircon is 49.76% zirconium, 15.32% silicon, and 34.91% oxygen. Okay, so the question is, what's the formula for zircon, right? What is zircon's formula? Okay. So here's how we do the problem, right? So what we do is we have to remember something about formulas. Formulas are a ratio of atoms, right? No, Zach, that's not right. Formulas are a ratio of atoms, and atoms they have individual masses, and so we're going to have to kind of pull in some of the stuff we've been doing to kind of work on there, right? Zircon, if I'm not mistaken, it's kind of the basis for like cubic zirconium. It's like never mind. It's a gem. It's a gemstone. Here, I'll show you some pictures of it. It's pretty. It's actually pretty. So here's zircon. Okay. Anyway. Zircon. 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 It's even Walmart blue. Yeah, Ms. Weaver. Oh, Weaver, I uploaded the final version of the worksheet to my Canvas if you want to pull it and upload it to yours. All right, so what we do is we say, okay, if we were to have, good, I did change it from the email I sent you, so just make sure that you grab the one that was on mine, the more recent one from this morning. Oh, good, perfect. Okay. So what we do for these problems is we imagine that we had 100 grams. Okay. So if we had 100 grams, the reason why we choose 100 grams is because of percentages, right? So if we have 100 grams of the compound, we would have 49.76 grams of zirconium, and we would have 15.32 grams of silicon, and 34.91 grams of oxygen. So if we have 100 grams of this compound, the percentages just turn into grams, right? So it makes it straightforward, okay? So then in order to relate grams into atoms, how do we relate grams into atoms? There's a nice unit that we've been using. Hey, Zach's got it. Moles. So what we're going to do is we're going to change all of these into moles. To do that, we need the weights from the periodic table. So oxygen is 16.0 grams in every 1 mole. Okay. Silicon is something that I don't have memorized. Where are you, silicon? 20 point something. I can't see that. That's really small on my screen. Silicon's 28.1. So 28.1 grams of silicon in every 1 mole of silicon. And then zirconium over in the middle here, 91.2. Okay, let me get the P table off. Oh, but again, so Chris, that doesn't matter, right? We're just using the ratio to change grams into moles. The answer here might be smaller than 1, which is fine. We're taking the percentage from the formula, right? Turning those into grams, and then converting these gram values into moles using the weights from the periodic table. So what we do is we're gonna get moles. So my calculator, right, I take 49.76 divided by 91.2, 0.546. I take 15.32. It's really important that you don't round too much here because it'll throw off your answer. So you got to be careful about rounding too much. 0.545. 2.18. Okay, so well, what does that tell us? Well, that tells us I've got this many moles of zirconium, this many moles of silicon, and this many moles of oxygen. Now, does that look like a formula? 0.546, 0.545, 2.18? What you can do, there's this convenient thing in math where you can take numbers to get a whole number ratio. And what we're going to do is we're going to divide all of these numbers by the smallest value, which is 0.545. And what you'll see is that 0.546 divided by 0.545 is essentially 1. 0.545 divided by 0.545 is, of course, 1. And 2.18 divided by 0.545 is essentially 4. So 114, that looks like a formula. ZrSiO4. Dog, says Johnny. So what happens is at this very last step, you should have numbers. Yeah, sorry, I'll slow down. We're going to do a lot more examples of these. I'm going to recap what we did. I'm going to do it a little slow. So the idea is that at this last step, you should have whole number ratios. Okay. 114. Yeah. So let me go back to it. Hey, lol, just lol, haha. Nice name. Thanks for the follow. Okay, so what we did, we started out, we took the problem gave us percentages, right? And we said, okay, if we had 100 grams, we would have the percentage as a grams of this many grams of zirconium, this many grams of silicon, and this many grams of oxygen. Okay. Hey, Streamlab stuff, see? 49.76 grams of zirconium, 15.32 grams of silicon, and 34.91 grams of oxygen. We took those gram values and we converted them into moles using the weights from the periodic table. So we looked up zirconium is 91.2, silicon was 8.1, oxygen was 16.0. We did these divisions and we got the value in moles. We had 0.546 moles of zirconium, 0.545 moles of silicon, and 2.18 moles of oxygen. Right? So with these mole values, I then looked at these three values and said, okay, which one of these values is the smallest? 0.545 is the smallest value. So I took these three values and I divided them all by 0.545. So I took 0.546 divided by 0.545, which is basically 1. 0.545 divided by 0.545, which is 1. And 2.18 divided by 0.545, which is 4. That means that my ratio for my formula is 1 zirconium, 1 silicon, and 4 oxygens. Does that make more sense, Chris? Oh, the shock chemist is rating. Let's go. Update on Brighton is going to be playing Shaw High School next Friday in a League of Legends match. So this is what the homework's going to be like, Lauren. Yes, some of the homework. We're back. All right. Let's do some more. We got more to do. Let's do another example. Have you guys done this, Shaw Russo's class? Have you guys done percent compositions and empirical formulas? Yeah, it'll be streamed, Jonathan. The esports team's gonna have a bunch of games being streamed next week. And yeah, that's a good question. What would happen if you had divided it by one of the other numbers? The ratio wouldn't come out to be a whole number ratio. Right? So our goal here is getting whole number ratios. Yeah, and so that's why we've divided by the smallest, is so we can kind of simplify it down to being 1. Okay. Number 2? Was that number 1? Yeah, number 2. Let's do another example. What if we have a compound that is, so unknown is 29.08% sodium, 40.56% sulfur, and 30.36% oxygen. Oh, so Anya, that has to do it has to do with how ratios work, right? So it's just as a simple mathematical like solution to ratios. So if I said I had 5 to 15, right? How do we simplify like 5 parts of one and 15 to another? 5 to 15 is the same as 1 to 3, right? Mathematically, the way we change 5 to 15 to 1 to 3 is to divide them both by 5, right? So if you ever have numbers that you're trying to figure out the simplest ratio between them, you can divide by the smallest. It's just kind of a mathematical thing, right? So if you're like, oh, 3 to 6, well, 3 to 6, if we divide them both by 3, that's 1 to 2, right? Yeah, kind of greatest common factor, but it's a little trickier than that because they're weird decimals, and so it's not always obvious like to look at. Which is why we just kind of go with dividing by the smallest, because that'll work. The numbers will work out that way. Math. All right. Let's do this problem the same way. We're going to do more examples. Yeah, I know it's not a satisfying answer, but yeah. Okay. Let's do another couple examples. So again, we've got the percentages. So we're going to start out with a 100 gram sample. Okay. So we're going to say, all right, if we had 100 grams, we would have 29.08 grams of sodium, 40.56 grams of sulfur, 30.36 grams of oxygen. Now, the problem with these problems is they take up a lot of space to write it all out. So you might need several pages for the homework. But the problems aren't hard, they just take a lot of space. Okay. So we've got all our grams, right? What's our next step? What do we need to do next? Yeah, we got to change them into moles. So I know oxygen, I've got oxygen memorized. It's 16.0. Okay. Then sulfur, I think it's 32 something, 32.1. So sulfur, 32.1 grams. And sodium, 22.99 or 23.0. Uh-oh, I heard a child hit something. Poor kid. He like ran into a door. 29.08, 23 grams in 1 mole, 40.56, 32 grams in 1 mole. Oh, oops, that should say sulfur. Sorry, sulfur. 30.36, 16 grams in 1 mole. Okay. Right, so now we do that math. We plug it into our calculator. Yeah, it sounded pretty loud. I don't know how loud it actually was. 29.08. My son's been having a rough day or a rough couple days. He just keeps like falling and running into stuff. 1.26. Oops. It sounds like something I would do. All right, so we have 1.26 moles of sodium, 1.26 moles of sulfur, and 1.90 moles of oxygen. So we do the same thing we did last time. We got at this point, we've got to turn it into a ratio. So to turn it into a ratio, we divide them all by the smallest, 1.26. Again, we get 1, 1, but we're actually going to get something weird on this last one. Hey, Cooper's got it. Good job, Cooper. Cooper's got a pretty good understanding of ratios. So when we do this last one, it actually comes out to be 1.5, right? So if we have a 1 to 1 to 1.5 ratio, yep, that's the same as a 2 to 2 to 3 ratio. right? So yeah, you guys got it. So then our final formula is Na2S2O3. And if I was mean, I would ask you to name that formula. What's the name of this compound? Because you should know the name of this compound. But I doubt you do. Sodium thiosulfate. Good, Lauren, you got it. Good job. Sodium thiosulfate. Look at you having your polyatomic ions still memorized. All right, so the idea, yeah. So if we go back to this ratio, this thing right here, 1 to 1 to 1.5, we can't write the formula as NaSO 1.5, right? That's not a valid formula. Valid formulas have to have whole numbers on the bottom. Okay, and so the idea that we have 1 sodium, 1 sulfur, and 1.5 oxygens, we can take that and we can say, okay, well, let's get rid of this decimal, right? And to get rid of that 5, that 0.5, we would multiply by 2. And so that's where we get this 2 to 3 ratio, right? A 1 to 1 to 1.5 is the same as a 2 to 2 to 3. I believe Lauren. I believe she remembered it. I'm going to trust her. Yeah, you can't have any half atoms. Yeah, the number of atoms, number of electrons, yeah. Okay, let's do another one. I'm going to have you guys see if you can do this one all on your own. So the formula is 26.58% potassium, 35.35% chromium, and 38.1 or 38.07% oxygen. So in an equation, like if you were balancing an equation, the coefficients just multiply through. So we're not going to be worrying about balancing equations here. We're just going to be focused on figuring out the individual formulas. So Chris is talking about like balancing equations. So when you balance equations, right, you still have to, it's similar because it's the whole numbers idea. You still have to use whole numbers when you're balancing an equation. And a balanced equation is an expression of ratios as well. But we're not worried about balancing equations. We're just focusing on figuring out individual formulas. Okay, so the formula for this compound is 26.58% potassium, 35.35% chromium, and 38.07% oxygen. See if you guys can get this one. I'll give you 2-3 minutes, and then I'll start slowly working through it. Trinity says, I don't got it. Okay, so remember the steps, Trinity. Take your percentages and turn them into grams. Take those grams and change them into moles using the weights from the periodic table. Take the mole answer, divide by the smallest to get a whole number ratio. So those are kind of our steps. Turns the percentages into grams, change grams into moles, divide by the smallest. The steps? Sure, Jonathan. Yeah. So the steps are to change the percentages into grams, change the grams into moles using periodic table, Divide the moles by the smallest mole. Yeah, so a couple of people are getting this K2CR2O7. Icy Snow was the first one, so I'll give them credit. Yeah, so let's see. For everyone else, let's talk through how we did that. So we changed the percentages into grams. Okay, I'm going to look up potassium on the periodic table is 39.1. Chromium is essentially 52. And oxygen is our trusty 16. So take the 26.58 divided by 39.1. We get 0.680. Again, 0.680. I should do somewhere the first two aren't the same. I should have varied these problems a little bit more, but that's okay. So we get our mole values, divide by the smallest, we get 1, 1, and then whatever this is. All right, so I get 3.5. So we're going to have to do the same thing we did in the last one, where we're going to have to double it, and that's why people are getting K2CR2O7. Potassium dichromate. Sure, Zach. So Chris, that's a good question. So it kind of goes back to, remember how we learned about all the polyatomic ions, and in a lot of the polyatomic ions we just had a bunch of oxygens. Oxygen is really good at wrapping around other atoms, and so like your chromiums can be surrounded by 2 or 3 oxygens, and in this case sulfur is surrounded by oxygens. Oxygen won't always be the highest number. In our next example it's not, but yeah. Oh yeah, sorry Trinity. No, Chris, it's a valid question. It's just there's a lot of compounds that do have a pretty good amount of oxygen, because oxygen is relatively abundant and relatively reactive. So a lot of things sometimes have a fair number of oxygens. It is a song. Yes, I know. Oh, it's a show. All right. Let's see. Yeah, potassium dichromate, Olivia. CR2O7's dichromate. Let's do another one. Actually, yeah, let's do one last one of these. This one will be simple. So, 40% carbon, 6.71% hydrogen, and 53.3% oxygen. All right, so 40% carbon, 6.71% hydrogen, 53.3% oxygen. Zach, there's still one more thing. There's still one more thing we got to do. There's one more complexity. One more complexity. And this problem, the reason I'm doing this last problem is going to be to illustrate that complexity. So we get 3.33 moles of carbon, 6.71 moles of hydrogen, and 3.33 moles of oxygen. Divide all these by 3.33. I get essentially 1, 2, 1. So does the mass of the element ever have to do the percentage of the problem? I mean, not necessarily. Heavier elements will potentially have a greater percentage, but not always, right? So it just kind of, the math will kind of work out to show you what the ratios are. And so we just kind of, we can't necessarily judge just by looking at the problem. I mean, hydrogen here is a low percentage, but because hydrogen has a low mass, there's still 2 of them in the compound. So yeah, it relates, but not in a meaningful way. Okay, so Lauren, just do the same order that the problem gives you. So because this problem lists carbon and then hydrogen and then an oxygen, just make sure your answer lists carbon and then hydrogen and then oxygen. Yeah, carbon water. No. Now, CH2O is formaldehyde. Okay. But there's a trick, because C2H4O2 is acetic acid, which is the active ingredient in vinegar. Okay. And C3H6O3 is lactic acid. Okay. So we have 3 compounds, CH2O, C2H4O2, and C3H6O3. One of them is formaldehyde, a preservative, right? Cancer-causing. One of them is vinegar, gives you that little tang to your food, right? A little sour taste. And then one of them is lactic acid. It builds up in your muscles after doing some sort of strenuous exercise. So the problem is, what's true about the percentages in these 3 compounds, or the ratio in these 3 compounds? CH2O, C2H4O2, and C3H6O3. Yeah, they're the same, Sadie. They're the same. So the issue is these 3 compounds have the exact same percentage of carbon, the exact same percentage of hydrogen, and the exact same percentage of oxygen. So how do I know if my compound here is formaldehyde, vinegar, or lactic acid, right? I have to have one more piece of information. Okay. What's the difference between what's one difference between these 3 compounds? The amount of atoms. Yeah, the amount of atoms. We can think about something we've used before. We can talk about the molar mass. Yeah, the amount of bonds. We can think about the total mass of a mole. So how much does 1 mole of formaldehyde weigh? If I had a mole of formaldehyde, CH2O, how much would that weigh? Yeah, it would weigh 30. How much does a mole of vinegar weigh? C2H4O2, a mole of acetic acid. It would be 60. And then what about lactic acid? Careful, Zach. Yeah, it'd be 90. Right? So if the problem gives you both the percentages and the molar mass, you can figure out the official real formula. So let's do one last example that illustrates this, and then we'll do a little more practice with this on Monday too. So one last example. Okay, this is actually, we're going to call this letter C. Yeah, so Chris, to answer your question of where do we get the 30, carbon is 12. Oh, oops. Carbon is 12 grams per mole, hydrogen is 1, and oxygen is 16. So 12 plus 1 times 2 plus 16 gives me 30, right? Because 12 plus 2 is 14, plus 16 gives me 30. Okay. Yep, it's just the weights from the periodic table. Okay, empirical versus molecular formula. Empirical is the simplest whole number ratio. Molecular, actual formula of the compound. Okay, so let's do again one last example. All right, we get so we have this unknown is 74.0% carbon, 8.65% hydrogen, 17.4% nitrogen, and has a molar mass of 162.2 grams per mole. One last example. Yeah, I might go a little bit over time, but I'm going to try to get it done in the next 5 minutes. Okay, so we have this unknown that's 74% carbon, 8.65% hydrogen, 17.4% nitrogen, and then it has a molar mass of 162.2. There's a couple ways to approach these problems. In my opinion, the one that makes the most logical sense is just to do what we've been doing. Okay, so we approach the problem the same way. We would say 74 grams of carbon, 8.65 grams of hydrogen, 17.4 grams of nitrogen. So 12 grams of carbon and 1 mole of carbon, 1 gram of hydrogen, 1 mole of hydrogen. Nitrogen's 14, right? I love these equations. I think it's really cool. But I'm also a chemistry teacher, so. Hey, thanks for the follow. I'm not even going to try to pronounce that. I'm going to call you Ao. So I get 6.17 grams of carbon. Sorry, Cooper. No, of course. Oh, sorry, that's not grams, that's moles. 8.65 moles of hydrogen. .24 moles of nitrogen. Okay, so again, divide by the smallest. Divide by 1.24. Okay, so our nitrogen is going to be our 1. What about the other guys here? This one's basically 5. And this one's basically 7. Okay, so our formula is C5H7N. Yeah, right. So my total money streaming is, I think I've made $25 off of streaming. Now, C5H7N, what we have to do is we have to think, okay, what's the weight of C5H7N? Right? 12 times 5 plus 7 times 1 plus 14. The weight of C5H7N is 81 grams per mole. Okay. Did I get a raise, Matthew? I don't think so. Okay, ice and snow's got it, right? 81 grams per mole. The problem told us it was 162 grams per mole. So how does 81 compare to 162? Yeah, we have to double it. So if we do C10, H14, and 2, that gives us 162. Now, question, what is C10, H14, and 2? Yeah, it's close enough. If we would have done more digits on these ones, we would get the 162.2. I just rounded too much. C10H14 and 2 is favorite chemical of the bathroom lurkers, nicotine. Bunch of vape addicts. Yeah, this is it, Cooper. You're good. Yeah, so there is, the worksheet is, go ahead, it's already published on Canvas. So let me show you guys that real quick. There's percent composition questions, then there's some empirical formula questions, then there's some molecular formula questions, and then this, page 2, we're going to talk about on Monday. So you can go ahead and download this and you can actually start working through it over the weekend, and it's going to be due on Tuesday. So say we all, I saw your recommendation, or I saw your question, a book for Gen Chem. For my class, for my AP course, I use Masterton. I use the book by Masterton and Hurley. That's my personal favorite. But there's all kinds of chem textbooks. I know a couple other people use Tro and like Tro. But yeah, I personally think the Masterton text is my favorite. What's it called? Chemical Principles and Reactions. Yeah. I mean, it's pricey, but you can find like really old editions that would be just as good if you're just looking for some chem knowledge. So yeah, no, that's it, everybody. Have a great weekend. If you haven't finished last night's homework, make sure to get that done. Oh yeah, no, it's a smaller text, Weaver. Yeah, for a new one. Yeah. I wonder why it's half off. Oh, it's only one left in stock. I wonder if is there an 8th edition coming out? I don't know. Yeah, the homework's posted. It's under modules. It's right here, chapter 2, part 3. I put it right at the top. I switched the order so that the new stuff is the top and the old stuff is at the bottom. Yep. No, have a good weekend, guys. Sorry I went a little tiny bit over.